it's doing it. You know, when I get down low, I'm going to see if it's level or if it's warped while it's making it. It crowns a little bit in that one section.
Yep.
Well, part of it's because I built a cavity over nothing. I don't know if you know that or not. That's why it's spooned up. Yeah, actually, I'd say that you want to kill the lights for a second?
Yeah.
I think I can, actually.
There it goes. Much better.
Now if I move this over the top a little bit, my favorite accessory.
Oh yeah.
I like this accessory so much I didn't offer it for sale to anybody else.
Huh. Well, yeah, the watchmaker light.
Yeah. Just for the engine. I mean, it just seems to work well. Alright, so at least you guys see one printer work. Here you go.
Okay. Then they're just divided by zero error right there. Gotta love that.
Is that my fault?
No.
You sure?
No.
You're welcome to blame it on me.
No. That's great. It's the infinite mirror thing. So, Plexus says, I prefer to use 3mm, however 1.75 appears to be winning the format wars. Your spec for 3mm, will you have support for 1.75mm? My preference would be to be able to insert a different feeder tube to support both diameters without needing a something.
Yeah. Well, here's the deal on that one. Don't even think about answering that question. That's a loaded one.
Okay. Backing away.
The mechanical design is compatible with any size from 3 down to 1mm. However, the intake and the material tube that comes from the back and the exhaust pipe that goes into the fusion chamber are specific to the material type. So you can actually rebuild the head if you want to for different material sizes, but you're not going to switch from 1.75 to 3 and back to 1.75. Let me tell you why. The different diameters really have a lot different characteristics as far as flow back. If you're pushing the material cold and it fuses and there's an extra gap in there, it comes back, it forms a plug, and it's a nightmare. It is the #1 reason why we were having problems with stripping the plastic. When you get, right now we're 10,000ths of an inch oversized and nominal. So if you're running 3mm, we've got about an 1/8 of an inch bore we put in it. If you're running 1.75mm, we're running an 0.79 hole, which is 2mm. So you're very close to being 10 to 12 mils, I think actually 8 to 12 mils oversized. This gives us the perfect solution to not having the hot material flow back and form a cold plug around the material. So when the material's coming in, it's coming down into your drive, and from your drive it goes into what we call the exhaust pipe. The exhaust pipe is under force. It's essentially a very short Bowden tube. When you're in force in there, you want that material to stay linear and you want it to stay fairly stiff.
Yep.
So we keep it cool. We have a special tower that we made. And no, it wasn't just our idea. Lots of people put fins on the exhaust pipe to keep the material cool. So that's a great observation, and it's an endless goal for everybody, is to control the temperature of the material on the way to the fusion chamber. Then it is forced into the fusion chamber. Now, I will say this: we came up with a really, I think, superior Teflon brass seal technique this week that I had not expected, and almost by accident. So it was fantastic, and I think it's going to become a standard. Not expensive for us, One of our problems was the material would come back out through the joint, but now we found a way to make a really nice cup joint for it. So anyway, it gets into the fusion chamber. You don't want it flowing backwards. It's got to be forcing the nozzle. And when you're using the small diameter like 0.4, 0.5 millimeters, you get a lot of reverse pressure coming up. So anyway, I'm not going to say one head prints every diameter of material. I think we did pretty good to have one head that goes between nylon, ABS, and PLA. And I'm not going to take a bow. Talman should take a bow. He's the one who made a nylon that's compatible in this temperature range and in a sealed environment.
Yes.
So thank you for sharing your technology with the rest of the world.
Plexus says, we, the printerbot community, have not found a way to eliminate stringing when using nylon. The best solution is set the non-print tool speed as fast as possible and don't use retraction. In other words, move the head as fast as possible to prevent stringing. So, interesting.
I didn't have much stringing action.
No. The string that we were getting was actually off of the ABS. But that's because we were doing because the slicer was going from, let's say, from this point all the way, traveling all the way over to here.
I have one of these that printed several
crazy.
more layers.
Mm-hmm.
The raft one. Have you seen the raft one?
I have not.
You went up like 6 layers high before it came off.
Oh, okay. And he also says, so you're saying the heads after rebuildable, you're saying the heads are rebuildable for both materials and filament diameter. That sounds good as long as the rebuild is easy and fast. Will the head support 3 and 1.75 millimeter plastics when they ship? Good question. I'm going to go check the, switch over the...
he did it to me again. He leaves me with those tough questions. You know, he's not getting a popsicle tonight. That's the way it goes. I'm going to eat them all. Okay, question is simple. Different materials, different material size. 2 different issues. When it's different materials, if the materials have a maximum service temperature of 260 degrees C or less. Right now we haven't found a material that we don't like, a plastic, that prints below the 260 mark, that you have any problems switching between. ABS, PLA, nylon, boink, 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 we can switch. We have switched back and forth nearly a dozen times in the last 3 days, just ping pong, and you know, it just continues to perform. So there you go. With different material size, that's a little bit of a pain. It's not a 2-minute fix. If it were me, I'd just buy a second head, but I know that's a couple $100, and $200 is $200. We can support 3 millimeter 2-day if that's what you want, and that's the way you want your head configured. We can also support 1.75 millimeter 2-day because that's what we're printing with. We found a lot more material was available at the 1.75 millimeter. We found that the control, although with the hob shaft the 3 millimeter should be no problem either, but we found that the control on the 1.75 made more sense as well. So you can, I know some people have an investment and they have some 3 millimeter stuff. I put it on eBay. I just go with 1.75 unless you found some unique application that requires it. That's our best advice. Okay, next someone's brought up the point that polycarbonate is 300 degrees C. Of course it is, and of course you want to print polycarbonate. I want to print polycarbonate. You can't print polycarbonate with the PTFE exhaust pipe. For that to work, you have to use our glass exhaust pipe, and we're not making that available yet, but we have it. And the reason we're not making it available yet is I ran out of time. I am still getting the other stuff ready, but we have the design where the liner is a high temperature material instead of being PTFE. And the reason why we haven't just gone with glass is I have some special people making us a special kind of a ceramic insert that lets us go all the way to 400 degrees C. And the reason for that is we want to print PVDF. And if you guys know what that is, it's a form of Teflon that's compatible with so many things out there. It turns brown in the presence of sulfuric acid, but still is quite functional, and it's used a lot in the semiconductor industry. PFA, that's another one we want to print, and it's a rock and roll because it comes on eighth mil or 3 millimeter approximately, and that brings up a good point. There is where I would use my 3 millimeter material handling, because the PFA I don't believe comes in 1.75 millimeter spool or rod. Anyway, these are kind of things. Oh, by the way, if you print PFA, it gives off fluorine gas. Has to be done in a well ventilated area. But what you can do with it is some pretty amazing stuff as far as chemical compatibility goes. All right. Well, that's really good information. Use goop. It's a glue to bond the canvas for nylon. And are you bonding it to a aluminum, or what substrate would you like to bond the canvas to? I mean, I'll get these guys to get one of this marked up. It's too bad it's too late for Hobby Lobby to be closed. Aluminum. Okay, well, we got plenty of aluminum. Have you tried to stretch your canvas like a picture frame, like the way they mount a picture, and just print straight on that? And can we use a nylon canvas, or does it have to be a burlap? Because I can get...
Yes, doesn't work.
Pardon?
It says yes, doesn't work.
Okay. I can get a picture frame or a silk screen. You know what? I got a silk screen. I bet you anything we could print on silk screen material.
Oh, yeah.
And it's tense. Just like Hutch at lunch.
Yeah. See, stretching doesn't work because the force of the nylon stretching overpowers the canvas.
I understand that. It makes sense that the canvas wouldn't have the material properties we're looking for. But some of the high temperature polyester, like what you see when you go to look at a silk screen, that bed put down, it'd be interesting to check that out. And they have metal screens too, because that's what I use for my stencils.
Okay.
So I don't know, if it's a texture orientation, that's one thing. If it's something else in the surface chemistry or attractiveness, this is actually turning out.
Oh, yeah. It is. It's actually...
Do I really have to sell this printer to somebody? Can't I just keep it, play with it?
Carl, we can always make more.
Okay. Yeah, unfortunately, that's true. Make sure to leave it cure for a full day. Man, thank you so much.
Thank you, Plexus.
Yes, really.
So I tried using contact cement and epoxy, and they soften with heat, but goop works so far.
Goop. Did you get it at Home Depot? We'll go online and check.
Yeah.
We love Talman. I mean, it looks
Oh, yeah.
awesome. It was kind of cool because printing, you could actually see the grid through the first couple of layers. Oh, any hardware store. There you go. What's goop? Oh, it says you can put it on your burrito. Oh, from the makers of Gorilla Tape comes Gorilla Goop.
Yeah.
Hey, I'll bet we could print this stuff.
Yeah.
I'm serious.
Yeah, we actually could.
I'll print a raft on the aluminum of this. It'll be perfect. It really will.
That would be, yes. They got a self-leveling non-sag. Oh, yeah. Oh, he's, Kavan says going out right now, I'll mail you at the hotel when he gets back.
Nice,
Okay.
Kavan.
Okay.
Have a nice
Great.
evening.
Yes.
Be safe there in the Philly cheesesteak area.
Yeah. So. Oh. Thank you for the link, which is Plexus sent us. It's eclecticproducts.com/ag adhesives _epoxies.html.
Sweet.
So HTML. So it's amazing goop. Ah. Actually, yeah.
Oh, they put a spray on goop.
Yeah. They've got RTV too.
Nice.
They're using yeah.
All right, Eagle and Jay's definitely got a fetish going on for chocolate. He wants to know what happened with the chocolate in the volcano.
Good question. Very good question, sir.
This is a little bit like spilling the beans before the beanstalk has come out.
Yeah.
So,
Should we hold back?
no, I'll just share what we've done
Okay.
so far, and this is actually 3-4 weeks back. I just love seeing that thing work.
I know.
Sorry, guys. we got the volcano, we whipped up the chocolate, we got it hot enough, it went right in, and we squirted it out. It never got firm. Turns out that you need to get certain types of chocolate that will harden again. Otherwise, this stuff was at room temperature, still so mush like mousse, like jello, like pudding, soft pudding, 5 days later. So we went ahead and created a new type of build platform, and we're not going to tell you anything about it. It will be a month, and then we're going to just surprise everybody. But I think you'll find it has to do with printing things at a different temperature than you would expect.
Yep.
Anyway, we'll leave it at that. Hey, Eagle and Jay, stop taking my ideas, okay?
Yeah.
You did just ruin it.
Yeah, you did.
We've told enough people about it. We have a Peltier chilled hotbed. We actually have a...
It's a chilled bed, yeah.
You know what? I was going to tell everybody about this anyway. We have a real problem. We have a real problem with our hotbed. You know? It does what I'd wanted it to do. Gets to 80 degrees, 83 degrees, no problem. I can boost it up to 100. The problem is I'm already pouring 120 watts into it, and I don't want to just throw away lots of heat. Because I'm heating something that's much larger than my build surface. So after careful review, we feel like the best heated build platform is yet to come. Don't fear. Don't fear. We're not going to hold up shipments, and we're also not going to forget all the guys that backed us. This is not a trick for us to get you guys to stick another $50,000 into your printers.
Nope.
We've got a design where it drops into a cutout, gives you your 200 millimeter square build platform, and only that part gets hot. It's insulated from the carriage. It doesn't add much weight to the system, and it heats up much quicker. It heats up on parity almost with the print nozzle, so you're not stuck waiting 5 or 10 minutes for your build platform to get to temperature, and it's flatter than before. And right now it's pretty good because we're printing on it all the time. You know what? This is like watching the Empire State Building being made. So you guys can just take a quick look. Probably.
That's good.
Okay. So
That's what
we'll look at the part up a little closer.
Yeah.
I'm hoping it finishes soon.
Well, we got,
How long?
I'd say a minute,
57 seconds.
probably. So, that is actually ABS, PB Nicholson. Yes.
It is
It is
a
ABS.
yeah. PLA's for. I mean, I didn't say that. I almost said a wrong thing. PLA doesn't serve the commercial needs that we have due to its temperature qualities.
Yeah.
Meaning, don't ever try and make anything for your printer out of a PLA. No, we didn't. Eagle and Jay said, you forgot, I have a desktop computer with a Peltier cooling system boosting a liquid cooler. We didn't forget. That's where we got our Peltiers from. You don't have those in your system anymore. You better check your computer. Now, years ago, when I made some DMA replicators, literally, I was using Peltiers for differential ping-ponging to cause thermal gradients to happen between two small slides. And so, this is a real special moment for me, man.
Plexus has a very good question. Who owns the patent on the cold bed?
No one.
And they wouldn't be able to.
I mean, if they do, just print it in Minnesota.
There's prior art that's already out there.
Actually, my ex-wife has the patent on a cold bed. That's why I slept on the couch for years. That was a terrible thing to say, but it sounded funny at the time.
Family friendly.
Yep. All right, let's take a look at this. My God, it's. You know what? Now it won't come off.
Oh, great! Here's a razor blade. Yes, sir.
Well, it'll come off now. Well, You know what I did different is I put a lot more of the ABS down. That's why you see all that white around here.
This is printing on glass, guys, so... Oh,
Yeah.
nice!
Wow.
Whoa!
I just love that finish.
Show it to the guys. Show it to them. Whoa.
I don't know if they can see the light.
Oh yeah, they can see the reflection. Oh yeah.
So that's actually the raft.
Yep.
Alrighty. Make sure my temperature's dropping. 64, 175. Looks like we're doing fine.
Printed quite nicely. It's the ABS juice, guys. And
Okay, here. Hold on.
so as you guys can see, yes, we are basically out of our ABS juice. Also, here again, if you guys are going to be getting any kind of jars in order to make your own, make sure that whatever you buy when it comes to the stuff does not have this rubberized seal, because the acetone will eat into it. You'll get this stuff mixed in with your ABS juice. It's not that big of a problem, but it doesn't look so pretty, and it does kind of destroy that seal. So, just a pro tip.
Wow, I can't believe that. Those holes came out. The
It's looking pretty nice.
well, I know we will be able to improve on it, and we haven't done any post-processing on this at all.
Until now.
And you know, the raft covered the holes to go up through there, but that's okay. No, it's okay because I had to bore the holes out. I made them small. We're actually going to tap these holes.
Nice.
So
Okay.
the idea was that the filament would go.
And yes, guys, if you were wondering, that is the green filament back there.
Yep.
And it is 1.75 millimeter. What are you looking for?
Well, I was going to get the micro switch from you.
Oh, okay.
So the idea was that the micro switch is going to mount about like this. Well, I can already tell you that
It's off by a little bit.
I'm off by a little bit.
Well, that's why we do these things.
Yeah, I'll make it a little bit lighter.
Well, did it hold up to tolerance of spec when it comes to?
It looks pretty good. I mean,
Because we did, you know.
I didn't model this and put it in place. I just measured it.
Okay.
I mean, a lot of what it did was quite nice. I like the layer consistency, and I like the way the material is going. These holes are a little bit tough because they're right on an edge. There's not a full support on it. And I'm going to drop the feed. Let me go ahead and re-slice this one up. I'm going to start another one.
Okay.
You can talk to them if you want. And I'm also going to change that, the holes to come over a little bit.
Let's take a look at it a little bit more. So the idea is that micro switches on the bottom. You're going to have a little mounting piece right here, so that on the side of your system, where your filament comes up, goes up through here, through the micro switch, and up here where you're supposed to have your holes, right here. Actually, let's take this and use that as a puppet. There we go. And we're going to tap these holes, and the idea for these holes is where you actually have the starting part of your Bowden tube, which is that part right there, along with your tube. So, a 3D printed piece going inside your system that works, and that is to spec. So, that was the idea. Alrighty. Okay. So, let's see. Yeah, the cool bed stuff, that's actually been out there for many years, actually. I think one of the very first patents on that was actually done by a baking company, as I was reading on one of them back in the 1800s. So they were using an ice-cold chilled plate in order to cool off certain materials. So, although that one took me a little while to dig into it. So, yeah. Just like a hot plate. Hot plates is basically the same thing as a hot bed. You're using it with a combination of materials. You could absolutely patent it if you wanted to, but it's not going to hold up because of the prior art. So there you go. And you know, just is what it is. The razor blade stuff to get. Oh, you said Plexus. Plexus says I clamped the canvas aluminum bed to the main aluminum print bed and then raised the Z home to account for the added height. Yep, it picks up the heat from the heat bed efficiently. Yes. So.
How hot does he take it?
Yeah, just out of curiosity, Plexus, how hot do you take your hotbed for ABS and for PLA and for polycarbonate and those guys? E1J says you need a razor blade to get that stuff off the Form 1 bed too. They hand you a paint scraper. Yes. In fact, one of our backers who is who's on tonight, I believe you're still on tonight, the Midnight Manufacturing Company was kind enough to actually give us a paint scraper, actually 2 of them. And this was a couple months back. We've actually been using it. In fact, we've been using it so much that one of the smaller guys has kind of disappeared, but the larger one is still here because it's a little bit harder to conceal. So yeah, I am in a manufacturing company. That's the 2 MCO for everyone who's watching.
Tell them to come by me lunch later this week.
I'm not sure if you heard that or not, but Carl says come by and
buy me lunch. I'm hungry. Whole Foods or bust.
He said come by for lunch. Or
Actually, we have a Thai restaurant. And I found drunken noodles. I'm now a drunken noodle fanatic. So
oh yeah,
come on over and we'll do some drunken noodles together.
Yeah, excellent. So
there's no alcohol in them.
Yeah, there's no alcohol before anybody asks.
But there will be chicken.
Yeah. It's good stuff. Very good stuff. Let's see, or paint spatula. Actually, yeah. When it comes to spatulas, we bought quite a few of them on sale, and we tested a couple of them out. They don't work as well. Metal spatulas do not work as well
You have to sharpen
as
the edges.
as your paint scrapers because the edges aren't as sharp as you may have just heard Carl say. So. Just keep that in mind if you ever buy a spatula for this particular application. Get one, and then make sure you've got a stone that you can actually sharpen that particular edge. So, Powers USA says, Drunken Noodles rock in Cambridge, Massachusetts. There's a place that makes some killer noodles.
We're on our way. We'll be there in the morning.
I think. Yeah, we're definitely coming up to Cambridge then.
No drunken noodle can be completely out.
Yes, many manufacturing company, you're correct. Yeah, you need to put an edge on the scraper for it to work best. Yeah, and
do you guys want to see me how to slice this?
Yeah, actually, let's show them this. Yeah,
come on over.
Okay,
you'll have to look at the screen, so I'll let Hush handle that.
Hold on one second. See if I can. Okay, there you go. It's good.
Alright, so I'm going to open my file. It's an STL file. You notice it came in small. You just click on this and it converts it to metric because this was drawn in inches. Don't ask, don't tell. It's obviously upside down. Click here. Run it over 180 degrees. Doesn't matter if it's plus or minus. And I'm actually going to rotate this around in this way. Oh, wrong one.
Just so you guys who are watching know, it's actually this piece that we're loading up. There you go.
Okay, and I'm doing that because this way I get more exposure to the south face.
Okay.
Alright, so then here I just click on that and hit the bullseye, and it's centered and it's justified. So now it is actually the way it looks to be. Alright? And that's cool. Now let's go look at the slicer configuration. And I have it set up for ABS running at 1.5 meter per minute, which is like just at 1 inch a second. 0.5 millimeter nozzle, the Z height. Yes, I know it's a crude slice, but again, we're trying to make as many parts as possible. We're trying to understand the process right now. We can thin it down, but there's no point in spending 4 or 5 hours just to find out that it's not sticking. So what we've done is expedited the build, and then we'll come back and we'll make it finer details slower prints, things like that.
Mm-hmm.
But first is to understand the